Okay, 5.5, we're looking at solving rational inequalities. Just like before, in solving equations, you're looking for 1 or 2 or 3 or finite amount of solutions. Whereas when you're solving inequalities, you have the potential for an infinite amount of solutions that are possible. In order to look at how you would solve rational inequalities, let's take an example. The first thing we will notice is that the difference between inequality and an equation is that you're going to have an inequality as the determinant between the two expressions. And the second thing is you never want to cross multiply. In order to make sure that, because of the process that we'll get to a little while later, you want to make sure that you don't eliminate any denominator. Right? So the first thing we're going to do is bring x minus 2 and x minus 2 over x minus 3 to the other side and keep it as the denominator here. Sorry. The first thing you want to do is identify your restrictions. We know that x cannot equal -1 and x cannot equal +3. So we've brought both to the same side, and now we want to simplify as much as we can so that we have just one fraction which is greater than or equal to 0, and then we can start the process of identifying the intervals which are going to be positive. So the first thing we want to do is get a common denominator, which would be x plus 1, x minus 3. This side here would be x plus 3 times x minus 3. And the second fraction would be x minus 2 times x plus 1. The second numerator would turn into x minus 2, x plus 1. And all of this is greater than or equal to 0. Let's continue to simplify. X plus 3 times x minus 3 would be x squared minus 9 minus. X minus 2 times x plus 1 would be x squared minus x minus 2 all over x plus 1, x minus 3. It would be very rare that we would ever need to expand or to FOIL the denominator. So if it's in factored form, leave it in factored form. At this point, let's continue to simplify. So x squared minus x squared will cancel out. -9 minus a -2 will be -9 plus 2, which is going to be 7. And then we have negative of negative is x. So we would be left with x minus 7 over x plus 1, x minus 3 greater than or equal to 0. Right? So everything we've done so far has been pretty much straightforward. It's been intuitive in terms of how do we solve equations, except that we have an inequality here. This is where things change a little bit, just like I did in chapter 4 when we looked at the difference between solving polynomial equations and solving polynomial inequalities. In the same way, in order to determine where in this function your y values are positive, we're going to have to use our number line. There is one difference though in the number line. With polynomial equations, the only way a graph could go from being, or a function could go from being negative to positive is to go through the x-axis. Now that we have asymptotes within our rational functions, we have to account for those as well when determining intervals of positivity and negativity. So we're going to have to include our x-intercept as always, but now we are also going to include the asymptotes. -1, +3. Now, we have to remember that if the question is asking when is this function greater than or equal to 0, you have to recognize that an x-intercept can equal 0, but the asymptotes will never equal 0. So one extra step to remember is your x-intercept, try to keep them with a closed circle to show that in a situation where it's greater than or equal to, the 7 is included, but the asymptotes are not included. Now what we have to do is figure out each of the intervals, just like we did in chapter 4. An interval, the first interval, which x is less than -1. So we plug in -1 billion, for example. This would be negative, negative, and negative. My equation would be negative. Now a number between -1 and 3, I'll choose 0. This will be negative, positive, and negative. Whole thing will be positive. Between 3 and 7, let's take 5. 5 minus 7 will be negative. 5 plus 1 will be positive. And 5 minus 3 will be positive. So I have one negative. My whole function becomes negative. Anything past 7, I'm going to choose a large positive number. be positive, positive, and positive. This whole thing will be positive. So where my solution lies is going to be in this interval and in this interval. Now pay close attention to how the difference between how you represent these intervals. So I know it's between -1 and 3, and there's a union of 7 till infinity. -1 is an asymptote. So my function cannot include, or my domain cannot include that asymptote. It must have a circle bracket. 3 is an asymptote because there's a circle around. That's how we denoted them. So it also cannot include. 7 is an x-intercept. So that is included. And infinity is a concept that we cannot achieve. So it would be a circular bracket. Remember, the only reason we have the square bracket here is because it's an x-intercept and because the question says greater than or equal to. If the question was simply greater than, we would have no concern for which one's the x-intercept and which one is the asymptote. But we do have an equal to sign, so we do need to account for that. That's what you're looking out for when you're looking at solving rational inequalities is, number 1, make sure you move everything to one side. Don't forget your restrictions. Get a common denominator and expand. Try your best not to cancel anything else because you don't want to forget about the asymptotes when you come to the end. Once you have the equation simplified and it's in simplified form with the 0 on the other side, you can go to your number line and try to determine where are your intervals of positivity and negativity. Once you have that, keep in mind which values on your number line are asymptotes, so they always get the circular brackets, and which values are x-intercept, so they may get a circle bracket, may get a square bracket, depending on how the question is set up.